guys, this is Professor Janacek, and I want to go over some examples where we find derivatives of functions. Now, there are all kinds of techniques for evaluating the derivative, but I want to go back to basics and use our limit definition. Now, there are two versions of this definition. We have that the limit as x approaches a of f of x minus f of a over x minus a is equal to f prime. And that is looks like the slope, and it is indeed the slope of the tangent line. There's also the limit as h approaches 0 of f of x plus h minus f of x over h. That's the limit of the difference quotient. And this is actually the one I'm going to use because I'm not evaluating my limit, my derivative at a specific a value. I don't have a specific a value. So I'm going to use the second one, the limit of the difference quotient. So let's take a look at f of x equal to negative 16x squared plus 96x. So f prime of x is the limit as h approaches 0 of, I'm going to start with in the numerator f of x plus h. So all I'm going to do is every time I see an x, I'm going to write x plus h. So that's negative 16 x plus h, quantity squared, plus 96 times x plus h. That's the first bit. Then after that, I have a minus sign, so there we go. And then after that, I have simply f of x. So write f of x as it was, negative 16x squared plus 96x. All of this, of course, is over h. So there's that h in the denominator. All right, now let's see. For the next line, still have my limit notation. Don't forget about that. Now I'm going to have to go ahead and evaluate this. I see I have an x plus h. All of that is squared. So remember, if you're going to take a binomial and square it, a plus b quantity squared is not just a squared plus b squared. It is not a squared plus b squared. In fact, what you actually get is a squared plus 2ab plus b squared. Of course, you might not even remember that. In fact, you don't even have to remember that. As long as you remember that a plus b, quantity squared, means to take a plus b times a plus b, and then take a moment, multiply that out, combine your like terms. I'm going to go ahead and do that. As well as distribute this negative 16 in there. So when you do that, you should end up with negative 16x squared minus 32xh minus 16h squared. All right, so that takes care of this bit. Take your time with that and make sure you multiply it all out, distribute, combine like terms. And then this next little bit, I can distribute the 96. And then here in the back, I'm just going to distribute that negative. Make sure this is all clear. Let's see, that should be a 96 plus 16x squared minus 96x. Okay. And we still have that h in the denominator. Whew, all right. Well, it looks like now, let me write that in limit notation so I don't forget about it. Again, do not leave that off. I can combine a few things. Negative 16x squared and positive 16x squared, those will cancel. Combine to make 0. A positive 96x and a negative 96x, those also combine to give us 0. So we can mark through that, might help us. So we have negative 32xh minus 16h squared plus 96h in the numerator. We still have an h in the denominator, but I noticed everything in the numerator has an h on it. So let's go ahead and factor out an h in the numerator. And then that will reduce with the h in the denominator. Ooh, how nice is that? And that was causing me a problem. That h in the denominator was why I couldn't just simply evaluate this limit at h equal to 0, because that h in the denominator caused problems. But now the h in the denominator is gone. Oh, that's fantastic. Now I can just use my normal limit technique, evaluate h at 0. We get negative 32x minus 16 times 0 plus 96. Of course, that 0 takes care of that 16, so we end up with negative 32x plus 96. And there you go. There's f prime. Oh, well, that wasn't so bad. All right. Let's take a look at example 2 here. F of x is equal to the square root of x. So we'll start by taking the limit as h approaches 0 of, again, using that f of x plus h there in the numerator. I'm going to write this as square root of x plus h minus f of x, that's just square root of x, and all that's over h. Again, make sure you see where that comes from up there. All right, well, now we have radicals. What do we do with radicals? Well, can't really combine them. Not sure what to do. If you ever get stuck with a radical and you don't know what to do with it, try rationalizing it. So let's go ahead and give that a shot. Let's rationalize the numerator, which means I'm going to multiply by the square root of x plus h plus the square root of x, so that in the middle, instead of a subtraction, I have an addition. But of course, I've got to multiply that in the denominator as well. Keep everything safe. So multiplying that in the numerator and the denominator. All right, so let's see, what do we end up with? In the numerator, if I multiply those first two terms, we get square root of x plus h times square root of x plus h, which I'll write square root of x plus h squared. And then let's see, the first term times the last term, that is square root of x times square root of x plus h. The inside two terms, and then multiply those last two terms. Notice one's a negative, one's a positive, so I get some subtraction there. Square root of x times square root of x, square root of x squared. Now in the denominator, I'm going to go ahead and leave this multiplied, factored out. I'm not going to multiply it just yet. If I need to, I'll do that in a bit. All right, so let's see, one little bit at a time. This bit, I can kind of get rid of that square and that radical. Don't forget about that limit notation. So we have x plus h. Also in the numerator, I noticed that this term and this term, they're the same, except one's positive and one's negative, so combine those, becomes 0. Then there in the back, I have minus square root of x squared, that's just an x. Here in the denominator, again, I'm going to leave it as is. But now in the numerator, I notice those x's, positive x and negative x, those will combine to give us 0. So in the numerator, all I have is an h. But now I can reduce that h. Look at that. Which again, that was causing a problem from the very beginning. If I wanted to take this limit from the very beginning, having h in the denominator as h goes to 0 was a problem. But now that problem is gone. So we have the limit as h approaches 0 of 1 over the square root of x plus h minus the square root of x. Oh, wait, that's a plus. That's a plus. Oops, plus, plus. Oh, isn't that nice? Now we can go through our typical evaluating the limit. So notice I'm not going to write the limit notation. If we simply replace the h with a 0, I think everything will work out just fine. So there in the denominator, we have the square root of x plus the square root of x, which gives us 1 over 2 square root of x. Now, we do have a radical in the denominator, which isn't the best way to leave this, so let's go ahead and rationalize yet again. This time I'm rationalizing the denominator instead of the numerator. That gives us the square root of x over 2x. Well, there you go. I do want to point out that this does work a lot like a function. If I wanted to evaluate f prime, say at 4, well, we know f prime of x is equal to the square root of x over 2x. So we could simply evaluate it just like a function. Let's see, square root of 4 over 2 times 4, that reduces to 1/4. So again, treat this like a function. That is what it is. All right, let's take a look now at example 3. Let's find the derivative of g of x equal to 1 over x squared. So g prime of x is the limit as h approaches 0 of 1 over, again, replace that x with x plus h, minus f of x just as it is, and then all of this is over h. So take your time with that. Make sure you see where that's coming from in that original definition. Okay, so let's see now. Let's first start by just dealing with the complex fraction. There are a few ways of dealing with this. I'm going to go ahead and just multiply this whole thing by the common denominator. So in the numerator, there's the denominator x squared and the denominator x plus h quantity squared. So let's just multiply that by the whole thing. So I'm going to, in the numerator, distribute. This bit gets distributed here and distributed there. So I'll go ahead and write it out so hopefully you can see what's going on. We've got x squared times x plus h quantity squared over x plus h squared minus x squared times x plus h quantity squared over x squared. That's in the numerator. In the denominator, we have h times x squared times x plus h quantity squared. So what we end up getting in the numerator, those two bits cancel, reduce, and those two bits reduce. So we have x squared minus x plus h quantity squared over h times x squared times x plus h quantity squared. All right, well, that's not too bad. Let's go ahead now and see if we can combine this stuff here in the numerator. What do we get up there? Take care of that. So I still have x squared minus, again, if you multiply this out, take your time with that. If you need, write it out twice, just like we've done a couple of times. That's a very common thing we'll see. That's x squared plus 2xh plus h squared. Which gives us x squared minus x squared minus 2xh minus h squared. Notice I just distributed that negative. And now in the numerator, I see I can combine the x squared and the negative x squared. So we get negative 2xh minus h squared. And again, I notice that I have an h in the denominator and h's in each of the numerator terms. So we'll go ahead and factor out an h in the numerator. You could factor out the negative if you'd like as well. I just need that h out there though. So now I can reduce this one h here. That's nice. That's exactly what I want. Again, it was that one h in the denominator that was causing problems, that was multiplying everything, making it 0. But now I think I'm ready to evaluate the limit. Let's see if, oh, and at some point I started changing those. Oh gosh, what did I do? What did I do? Oh, these should be h's, not x's. I'm sure y'all are all like, wait a second, what are you doing? That's h approaching 0. H is going to 0. Alright, that's better. Now, let's go ahead and let h go to 0. So we have negative 2x over, oh, you know what? I can, well, I'll do that in the next step. X squared, oh, actually that is not x squared, but x to the 4th. We can reduce this to negative 2 over x cubed. Well, there we go. I do want to point out that originally g of x, 1 over x squared, could have been written as x to the negative 2. And going through all of this, we would end up with g prime of x being negative 2. Notice here it is, negative 2 times x to the negative 3rd power. All right, well, there you go. Whew, done with that. Enjoy.